Field test, take one.
Hello there. I hope I did not startle you. My name is Nebo. I take care of this house and watch over the neighborhood. I just wanted to say hello. It was nice to meet you. See you next time. It is Yuli. Good afternoon. I hope you are well.
Hello, so as you can see from the field test there, development has been progressing very well over the Christmas holidays. It's given me a lot of time to work on the solution, and the field test has gone very well. I've actually progressed even beyond there, so I'll show you the details in a moment. I think at this point it's probably worth delving into how the logic works a little bit for those who haven't watched the original videos which show how I re-architected the AI platform. And that'll let you understand how it works so that you can leverage it if in your own solutions, and also modify the code if you want to. So let's take a look at that. So the main bit of code running on the client side is the robot AI client.py. Now what this does, it's constantly looking at the message queue for messages there, and when messages come in, it takes action on those, either calling in the library of code in client_motion or the library of code in client_voice. Now there's a couple of child processes that are spawned by that, so these run separate from the main bit of logic there. The motion sensor, which I'm using heavily in my solution at the moment, and the voice sensor. Now I'm not actually using the voice sensor. You may remember I was having some debugging issues there. It was crashing whenever it translated speech to text. So we'll introduce that at the moment, but let's just discount that as a part of the solution at the moment. You then have the brain side of things, and this is where I've pushed off all of the machine learning logic to. It also is there polling the message queue, looking for work that's come from any of the client devices, and it will call a library of code depending on whether motion or voice demands or processing has come from the client devices. So let's look at what happens when, say, motion is detected by the motion sensor pi, because that's the main bit of work we're doing. When motion is detected, it will send a message directly down to the robot brain from the motion sensor pi logic via the message queue. The brain will then process that using the library of functions in brain_motion to try and detect whether a person is found in the image. If a person is found, or regardless, actually it sends the results back up to the originating client via the message queue, and if the person is found, it will then take action, and it will use the library of motion detection functions on the client side. So that's, I guess, the first scenario where, for instance, it might want to then start recording the video. How would it do that? Because essentially we've got two separate processes there. The robot client process, which is running and is separate from the motion sensor pi. They don't necessarily, well, they don't talk to each other, but they can effectively do so through the environment variable. Now this is a shared dictionary object into which you can put virtually anything, and this keeps current context basically, so that what I can do in the client_motion there is set a flag in the environment to say, hey, it's time to start recording video, and then as the motion sensor pi function is constantly looping there, it can pick that up and go, okay, I'm going to start recording video, and it will do so once a person has been detected for security purposes. Again, depending on a flag in the environment as to whether I'm in, say, just friendly mode and talking to people on the street, or whether I'm in secure mode and I'm recording video for possible theft or something like that may occur. So let's look at another scenario. So let's say I am in the friendly mode here. So in that case, my take action function would send a message down to the brain. The brain would, in that case, then run a function to get all of the chat text that it needs from its database there, and it would send that back via the message queue to the client. The client would then detect that this is not a motion detection action that needs, it's a voice detection or voice action that needs to be kicked off, and it would start that chat process. I could also at that point start recording the video if I want to see people's reaction as the AI starts talking to them in the street and wishing them a good day and that sort of thing, like the video you saw at the start. So that's essentially how it works. Let's look then at some of the additional progress I've made, or in fact let's look at some of the code elements here, and we'll walk through so you can understand how it's actually doing these things we've shown in the diagram there. So here we are at the GitHub repository. If we take a look at the Robot AI client, basically it sets up some variables and parameters. This is the callback function that will be actually called whenever something is detected in the message queue, and you can see here it checks what sort of activity needs to happen, whether it's motion or whether it's voice or whether we're just sending the or it's the receipt of the environment variables. It comes down here, sets up our actual environment variable on the client device. It then kicks off the motion sensor here if the parameter in the config file is set to true, similar with the voice sensor, and then comes down here and starts actively monitoring that message queue, in which case when messages are received, as I mentioned, it'll kick off, it'll call out to the callback function. Now let's take a look at what happens with the motion sensor. So the motion sensor logic here basically has a loop that keeps running, and it's looking at a parameter in the environment variable called motion. That basically says whether we're going to detect motion. If it's set to true, it kicks off detect Pi camera, which in turn goes into another loop and keeps checking that variable periodically in case motion's turned off, in which case it comes back in here and waits until it's checked again. So that means you can switch motion on and off using that parameter in the environment. So looking at the detect Pi camera function here, we get down in here, and basically what happens is it gets into an infinite loop here. Every 0.3 of a second it runs the detect motion function, and let's jump out to there to see what happens. So the detect motion function will take a picture. It will then compare that to the average of other pictures to work out whether something's changed. That says whether there's been motion or not, and it then returns the result to say true or false, which after that's been run every 0.3 of a second, it comes down here and then decides, okay, so are we at the point where we need to start detecting? There's a bit of a warm-up time for the camera. If we are configured such that we need to send this off to the brain, it then sends it to the brain using the send image function here, and there's an upload every parameter here, and that kind of determines that sort of I think it's about every 3 seconds it sends an image across there regardless of whether motion is detected or not, and that enables us to have the website where it's constantly showing the updated imagery. And you can see here I mentioned how it checks the environment variable also to see whether we need to save video, which stores a date time there, and once it's hit that point, then it writes the video out to a file using another function here, and these are these helper functions which write the video and send the details through to the brain. So that's how that works. If we then look at what happens when a message comes back from the brain in the client motion here, you'll see it comes down and we're detecting both persons and faces now. So you noticed in the intro video there how it did recognize me. One of the problems though is because the responses to actions is a single process, it needed to go through that whole full lengthy chat, even though it detected and recognized me quite early on. So that's something I need to sort out in terms of the architecture. It's a little bit of a problem that all works in serial, because I'd like to interrupt that chat in order to say, hey, oh, okay, it's Lee Yu, welcome home, how was your day? So I'll need to improve that at some point in the future, as I marked here with the to-do. But once persons are detected, it sort of comes down here, and this is where it actually starts to do its activities. So that's a quick overview of the code. Let's now take a look at where we're at the current point in time. So here is the feed on the right hand side showing the most recent video in that website on the server, and the debugging of the client on the left. You can see as the trees are moving there, it's not really triggering any motion, which is a good thing. I believe that's the blurring of the imagery. As soon as a car comes into the frame, it's triggered motion. No persons are detected, you can see in the debugging there, even when I put my hand out. But once I step into the frame, it detects a person, and at that point in time it sets that parameter that says it's going to be time to write the video to disk in about 30 seconds. The way it works is it's using a ring buffer object to constantly keep 30 seconds of video in memory, and by setting a future date time, I can effectively say this is the point at which I want you to write that to disk, and you'll see that come up there on the debugging showing that it's written the file to disk. Here you can see the Pi fixed into the fence. It rained all last night, and you can see a little bit of moisture got in, but given the amount of rain, it's only a tiny bit, so I think it's pretty safe in there. It's very solidly fixed in, and I've made an aluminium faceplate here, which eventually needs a little bit of a cowling on the top, but you can see here there's the camera, there's the speakers, the microphone holes, and I'll be later on putting in a button here, which hopefully will be the subject of the next video. So I'll end this video there. Thank you very much for watching, and if you want to see the next video and be alerted, please click on the subscribe button or a like, and I'll see you next time.